Hello everyone, once again to this lecture 2 of high voltage engineering. Here we are having mechanism of gas insulator and continue our particularly part where we find out the ionization of collision. In this particular part, we will continue toward the different type of ionization processes. First is photoionization process. It is a basic phenomena where ionization is caused by radiation, and it is called basically it is an interaction of radiation with matter. As you see in the given below diagram, it is the same principle as we used before, where we put a high radiation of radiation like UV light put on some atoms having some insulations of gases, then the electron having the high energy getting by some radiation can be quit by this particular atom. As we say, the existed atom emit the radiation when the electron return to the lower state or the ground state. This particular process of getting the atom from electrons from an atom by absorbing some radiation from UV rays, it is this particular method is called photoionization method. It is kept important that the particularly radiation, the energy of this UV radiation or high radiation matters should be greater than the energy of your electron having in the outermost circle. Okay. This particularly given by some Planck constant S, C and delta lambda, that is wavelength of incident radiation, given by some below this formula where given that 1.27 of Vi basically the electron having the ionization energy on the outermost cell is greater than the lambda given wavelength of your incident radiation. It always be there, it's always be greater than. So higher ionization energy for getting the electron from the its particular outer shell, the wavelength of that particular radiation should always be having the shorter wavelength. It always be compulsory rated, and usually we will know that this particular wavelength having the wavelength range around the 1250 Armstrong around it. So it is given for almost all the gases. In this particular cases where we are talking about the ionization processes, one of the secondary ionization process, it is a direct ionization process. Now we're talking about the secondary ionization process where the electron are being ejected, ionized, having the not directly by indirect method. First is electron emission due to the positive ion impact method, where we having the some positive ion formed due to the ionization by collision methods are being having some positively charged method are travel to the cathode. Whenever this positive ions approaching the metal cathode can cause emission of electron from the cathode also, giving the kinetic energy impact. Like as we see in the first method of ionization collision, let's assume having the positive ion from this particular side, when we reaching to some of the metallic cathode, this will provide two type of things. First is providing some kinetic energy to electron, and second it will ionize the particular ions also. This work function is given only to the metal cathode only, and the first it will how will act as a secondary ionization method. First it will eject the electron from it, and secondary it will neutralize the ion also. It will getting both the way, and this particular position of the process is also measured by the Townsend secondary ionization coefficient. How much electron are being ejected and how much electron are act as a neutralized ion. Second method of ionization process will be electron emission due to the photon, where we having some electron to be escaped from a metal. It is due to the enough energy to overcome the surface potential, as we know from the previous supply also. If electron getting a sufficient energy from the UV rays or cathode ray, they will escape from the atom also. As you know, this particularly UV rays, okay, having the some suitable frequencies can have only be emitted, electron only be emitted when the UV rays having the uh, wavelength or energy should be greater than the electron. Okay, given the below formula where frequency is given by lambda V is equal to 5 upon H, where incident energy having the greater frequency than threshold frequency, or as mean by kinetic emitted electron. Third method, that is called electron emission due to the metastable and neutral atom. It is a basic formulation where we say some metastable atom having them some lifetime expectancy of 10 to the minus 3 seconds compared to some ordinary 10 to the minus seconds electron when ejected from the this metal surfaces, it will causing the total energy to overcome this particular barrier of a work function and ejected from the ion particles. This particular process is very easy, and metastable atoms use this particular process more usually, where the interaction of helium atom with the clean surface of molybdenum and nickel are being performed usually, and having the kinetic energy very high, it is 1000 electron volts around. This all methods, how much electron arc should be ejected by all different methods, can be calculated by one of the method that is called Townsend current growth equations, where we assume if there is a n0 electron are emitted from electron. Let us assume, as will give you idea, this particular thing we will teach in previous lecture by ionization collision method, where we consider from the negative plate there is some electron are be ejected to cathode plate. If the UV light are present on the particular insulating material, more electron that are getting from negative plate, more electron are getting to the positive side of the plate. Now we have to calculate how many electrons are been there, and how the particularly current should be go by this UV radiation method. So let us assume the n0 electrons are being emitted from the cathode. When one electron collide with a neutral atom, a positive ion electron is formed. Okay, that is the case. If negative electron is coming from the cathode side, it will collide with one of the neutral particle or atom. It will causes some more electron to be getting in the particularly insulation material and causing the atom to be a positive ion. It's called ionization collision method. As you see in this particular diagram, having cathode and anode plate having the distance d, small d should be there. Cathode having, let us assume, in x-axis position having the value of x equal to 0, and anode having the at the x-axis x equal to d. If we assume and number of electron getting to the cathode side are n0, and where the number of electron, as we know by the UV radiation, more electrons are been getting. If we assume the number of electron getting toward the anode are nd, nd should be always be greater than n of 0 from the formulation of the ionization collision method. Now the variation of this function, how the electrons are being more and more are being ejected, by the study of Townsend. He found that there is an increase in proportionality of voltage as the particular UV rays are being count upon any insulation material. This particular curve show you where the voltage should be incremented for a particular time of current. Okay, at particular current I0, current should be constant for a particular voltages. Okay, particular voltage ratio, and after this, when a threshold is passed, current should be accelerated so much high. Okay, this exponential rise of current we have to be noted in current growth equations, where we show the variation of this current as a function of voltage studied by Townsend. As I say you previously, this current is first increased proportionally to the voltage. It is a basically linear motion firstly in the first particular part, and in second particular part, as the voltage increases, v by d increases, the electron are accelerated more and more and collide more and more. Okay, so as the voltage increases, current also increases in the particular manner. This particular increment in current can be given by Townsend coefficient, that's called Townsend first ionization coefficient, alpha. Alpha is basically number of electron produced by the electron per unit length, is the number of electron that are produced by the electron atom. Let us assume for how much electrons are being condensed to the anode part. Let us assume number n0 is the electron emitted from cathode. One electron collided with the neutral part as if from the ionization collision method. If x is the distance x from the cathode, okay, let the number of electron will be nx. At particular from small distance of x, the number of electron cumulative at the x part is nx. The rate of rise of current should be given by dnx is equal to nx upon alpha dx. Okay, and this giving the some nn logarithm, it equal to nx equal to alpha x plus a, giving rise to one of the major function of this particular formula. We will give the unknown number of electrons getting toward the anode side can be calculated by function of exponential e equal to a by x, where x is basically तौर पे distance between cathode and anode. Greater would be the size between the cathode to anode. There should be larger should be electrons emitted from cathode to anode morely. Okay, this is one of the fundamental growth equation. This should be realized by you. AD equal to I0 E by alpha AD, where A0 is initial current, where EAD is a electron avalanche. And this particular equation one is called Townsend current growth equation from primary ionization method. Okay, thank you so much for this particular lecture. We will find out about the Townsend first coefficient equation. It is a very important for RGPV part. Thank you so much for today's lecture. Have fun.